So you know when this happens and you're like, wait, what? How can you just do that? Where'd the plus minus sign go? Where'd the 1/2 go? Where'd the e to the c go? Well, today we're going to be answering that question. What's happening here is that everything is getting absorbed into the constant c, and we're going to talk about exactly how that happens. Let's take this separable differential equation as an example. The first step is to separate variables. We'll multiply both sides by dx to move this dx over to the right side. Then we'll divide both sides by 2y plus 2 to move that to the left side. Now we have the y's on the left and the x's on the right. Then we integrate both sides of that equation. Remember that whenever we integrate, we need to add a constant. So since we integrated both sides, we'll add c sub 1 to the left and c sub 2 to the right. Our goal now is to take this equation that we have and solve it for y. Getting to this point was just about setting the foundation with a separable differential equation. But now we're going to solve this for y, and this is where some interesting things are going to start to happen with the constants. The easy first step is to subtract c sub 1 from both sides. Now here's where things start to get tricky. We can actually combine c sub 2 and c sub 1 together and just call the result c. Now think about it. They're both constants. If we knew that c sub 2 was 10 and that c sub 1 was 7, couldn't we just say that c sub 2 minus c sub 1 is 3? All we're trying to do here is solve for y, not c sub 2 or c sub 1. So nothing's lost in the problem by combining them into one constant and calling the new constant c. We just know that instead of 10 minus 7 in place of c sub 2 minus c sub 1, we'll just have 3 in place of c. Now we'll multiply both sides by 2 to get rid of the 1/2 on the left. This will give us 2c on the right. But, just like before, if we imagine that c is 3, then 2c would just be 6. Either way, whether we leave it as 2c or simplify it to c, we'll get 6 out here on the end, so we might as well simplify 2c to just c. Now we'll raise both sides to the base e to cancel out the e and the ln on the left. We can also use exponent rules to break apart the right side. E to the 2x plus c is the same as e to the 2x times e to the c. But remember, the exponential e is also just a constant. In fact, it's about 2.7. So e to the c is just a constant as well, and we can call e to the c just c. And because c is a constant, we can move it out to the front here to act like a constant coefficient. To get rid of the absolute value bars on the left, we have to add a positive negative sign over here on the right. But the c can absorb that as well. We'll subtract 2 from both sides, and then divide both sides by 2. That'll leave us with 1/2 c on the right, but 1/2 times c will still just give us a constant, so we can again absorb that 1/2 into the constant c and just leave the c. The point here is that whether you're multiplying a constant by 2, raising it to the base e, taking the positive or negative constant, or dividing a constant by 2, all of these can just be absorbed into the same constant c.